Now, something incredible begins. A tiny whisper in the void, a slight gathering of dust and gas, so faint that it almost seems invisible. But this faint whisper holds the secret to everything, the very first spark of creation. In this quiet corner of the universe, invisible forces begin to pull. A force so powerful that it can shape entire worlds, gravity. Slowly, it draws dust and gas closer, tighter, denser. Over millions of years, this invisible force spins and twists clouds of cosmic dust into beautiful shapes. From this swirling chaos, the first stars ignite, pockets of blazing light born from invisible pressure and heat. Stars that will live and die, exploding in titanic supernovas. Scattering the very elements that build planets, oceans, and even life itself. And with these stars come the very first galaxies, massive islands of light and matter drifting through the cosmic ocean. Spirals, ellipses, irregular forms, each with billions of stars. Some young, some ancient, some home to mysteries we have yet to understand. But here's the astonishing part. This cosmic dance, this grand, silent symphony, has been playing for more than 13 billion years. And every atom in your body, every breath you take, every moment of your life, is connected to this magnificent story. As our journey continues, let's zoom into the very beginning, the raw materials that make up everything in the universe. Space isn't empty, it's filled with enormous clouds of dust and gas, mostly hydrogen and helium, floating silently in the vast darkness. These clouds are called nebulae, the cosmic nurseries where stars and galaxies are born. Imagine a giant cloud, thousands of times bigger than our solar system, made of tiny particles of dust, frozen gases, and invisible atoms. Despite their size, these clouds are incredibly thin, far emptier than the best vacuum we can create on Earth. But inside these clouds, something magical happens. Slight differences in density, tiny clumps, start to appear. These clumps slowly grow heavier, pulled together by gravity, the invisible force that shapes our universe. Gravity works silently but relentlessly, pulling dust and gas closer, making the cloud denser and denser. As these clouds contract, they start to spin, slowly at first, but over millions of years, this spin becomes faster, shaping the cloud into disks and spirals. This is the very first step in the birth of stars and galaxies, the cosmic dance of dust and gas, pulled by gravity, setting the stage for creation. Now that we understand the cosmic clouds of dust and gas, let's explore what happens when gravity takes full control. As the cloud gets denser, its own gravity pulls it tighter and tighter, causing it to collapse. This collapse isn't quick, it takes millions of years. But during this time, the cloud's core heats up. The pressure inside grows so intense that atoms start to slam into each other faster and faster, raising the temperature to millions of degrees. Eventually, this heat triggers a critical process, nuclear fusion. Nuclear fusion is the power source of stars. It's when hydrogen atoms combine to form helium, releasing an enormous amount of energy. This energy pushes back against gravity's squeeze, creating a delicate balance, and a new star is born. Before a star fully ignites, it's called a protostar, a glowing ball of hot gas, still gathering material from the surrounding cloud. Sometimes, these protostars are surrounded by swirling disks of dust and gas, where planets might one day form. Not every protostar becomes a star. Some fail to ignite, fading back into the cosmic dust. But those that do shine, lighting up the darkness, and starting their lives as the building blocks of galaxies. As stars are born from collapsing clouds, they rarely form alone. Instead, they are born in groups, called star clusters. These clusters can contain hundreds, sometimes thousands of stars, all bound together by gravity. Imagine a bustling cosmic city, where stars live close enough to influence each other's paths. Within these clusters, stars can interact, sometimes passing close enough to exchange material or even affect each other's orbits. These star clusters light up the nebulae, making them glow with stunning colors we see in space photos. Over time, clusters can spread out or merge, becoming part of larger structures, galaxies. But the story doesn't stop here. As gas and dust continue to swirl around young stars, disks form, the birthplaces of planets and other celestial objects. In fact, Some of these swirling disks may one day give rise to solar systems, just like our own. Star clusters are the stepping stones in the grand construction of galaxies, collections of stars, dust, and dark matter woven together in cosmic harmony. From clusters of stars to colossal cities of billions, this is the birth of galaxies. Look up at the night sky and you'll see countless galaxies, swirling spirals like our Milky Way, massive smooth ellipticals, and wild irregular shapes, each a cosmic masterpiece. But how do these cosmic giants form? It's a story of gravity, time, and sometimes violent collisions. Imagine two giant star cities, hurtling through space, slowly drawn toward each other by gravity's irresistible pull. As they collide, gas clouds smash together, sparking brilliant waves of new star formation, a cosmic fireworks show that can light up the darkness for millions of years. These galactic collisions don't destroy, they create. They shape galaxies into new forms, twisting spirals, puffed-up ellipticals, and chaotic irregulars. Spiral galaxies spin gracefully, with arms full of young, bright stars, while ellipticals glow with ancient, cooler stars, the wise elders of the cosmos. And somewhere in this cosmic dance, black holes lurk at the center, mysterious engines that influence the fate of their host galaxies. This cosmic drama has been unfolding for billions of years, shaping the universe we see today. But galaxies don't live in isolation. They are part of a vast cosmic web, giant filaments of dark matter and gas connecting clusters across millions of light years. And it's along these filaments that galaxies form, grow, and collide, a grand cosmic network beyond our wildest imagination. As we admire the beauty of galaxies, a big mystery hides in plain sight, an invisible force shaping the universe, dark matter. We can't see it. We can't touch it. But we know it's there, because without it, galaxies would fly apart. Here's the puzzle: when astronomers measure how fast stars orbit the center of galaxies, they find something strange. Stars far from the center move much faster than they should, faster than the gravity from visible matter alone can hold. This means there must be some unseen mass, a mysterious substance called dark matter, surrounding galaxies in huge halos. Dark matter doesn't emit or absorb light, making it completely invisible. But it's the glue holding galaxies together, making up about 85% of all matter in the universe. Without dark matter, galaxies as we know them simply wouldn't exist. This invisible force guides the formation of galaxies and clusters, like an unseen cosmic architect. If dark matter is the invisible glue holding galaxies together, then dark energy is the mysterious force pulling the universe apart. In the late 1990s, astronomers made a stunning discovery: the universe isn't just expanding, it's accelerating. Imagine blowing up a balloon. As it inflates, dots on its surface move away from each other. But instead of slowing down due to gravity, the expansion is speeding up, as if an invisible engine is pushing galaxies farther apart. This strange force is called dark energy, and it makes up nearly 70% of the total energy in the universe. Dark energy acts like a cosmic anti-gravity, driving the universe to grow bigger and colder with time. What dark energy really is, no one knows for sure. It's one of the greatest mysteries in modern physics. But its effects shape the ultimate fate of the cosmos, whether it will expand forever, rip apart, or maybe slow down someday. Understanding dark energy is key to unlocking the future of everything: stars, galaxies, and even us. Stars are the true engines of the universe, born in clouds of gas and dust, living incredible lives, and dying in spectacular ways. It all begins in a nebula, a cosmic nursery where gravity pulls gas and dust together until a new star ignites. Young stars shine fiercely, burning hydrogen in their cores and lighting up their surroundings. Stars come in many sizes, from small, cool red dwarfs to massive, blazing blue giants. The bigger a star is, the faster it burns through its fuel, living a shorter but more dramatic life. Eventually, a star runs out of fuel, and its fate depends on its mass. Small stars slowly fade away, turning into white dwarfs, dense, dim remnants that cool over billions of years. Massive stars end their lives in cataclysmic explosions called supernovae, blasting elements into space. These explosions forge heavier elements, like gold, silver, and uranium, seeding the universe with the building blocks for planets and life. After the blast, what remains can be a neutron star, a city-sized ball of superdense matter, or a black hole, a mysterious point of infinite gravity. The death of stars is not an end, it's a beginning, spreading life's ingredients across the cosmos. The story of galaxies and stars brings us to a very special chapter, the birth of planets, and the origins of life itself. Around many young stars, vast disks of dust and gas swirl in a cosmic dance. Within these protoplanetary disks, tiny dust grains collide and stick together, slowly growing into larger rocks, then into planetesimals. Over millions of years, these planetesimals merge to form planets, moons, and other celestial bodies. Our own Earth was born from such a swirling disk around the young Sun, nearly 4.5 billion years ago. But what made Earth so unique? Why did life take hold here? The answer lies in a perfect mix of conditions: liquid water, a stable climate, protective atmosphere, and the presence of essential elements forged in the hearts of ancient stars. Life began as simple molecules, building blocks that, over billions of years, evolved into the rich diversity of organisms we see today. Every atom in your body was once part of a star, a cosmic legacy connecting us all to the universe. So, when you look up at the stars tonight, remember, you're looking at your cosmic ancestors. We started this journey in the cold, dark void of space, where dust and gas quietly gathered under the invisible pull of gravity. We watched clouds collapse, stars ignite, and galaxies form, massive cosmic cities spinning in the grand ballet of the universe. We discovered the unseen forces, dark matter and dark energy, shaping the fate of everything around us. We witnessed the birth and death of stars, cosmic explosions spreading the very elements that make up planets and life. And finally, we saw how from stardust came planets, and from planets came life, including us. This story isn't just about distant galaxies or ancient stars. It's about connection, a cosmic thread that links every atom in your body to the universe's very beginning. We are the universe made conscious, a way for the cosmos to know itself. So next time you look up at the night sky, remember, you are part of this incredible cosmic story. And that story is still being written, every moment, everywhere around us. Thank you for joining this journey through time and space. Stay curious, keep exploring, and never stop wondering. As we end this incredible journey through the universe, remember this: we are not separate from the cosmos. Every atom in your body was forged in the heart of ancient stars. We are made of stardust, connected to every galaxy, star, and planet that has ever existed. The universe is not just out there, it's inside us, a story of creation, destruction, and rebirth. Our existence is proof of the universe's endless capacity to create, evolve, and surprise. So look up at the night sky with wonder, knowing that you are part of something truly magnificent, a cosmic masterpiece still unfolding. Thank you for watching. Keep exploring, keep questioning, and keep dreaming. If you loved this video, make sure to subscribe and hit the bell icon for more incredible space adventures.